here, and you are up. Yeah, you want to sit and here's your microphone, so we're recording. Okay. And you'll need to advance your own slides. Stand. It's hot.
Well, I'm going to talk about my design is a quality blower. This is my outline. I'm going to present the overview of my design, the problem statement, the approach, the execution, and I have some demonstrations and my conclusions. Well, this is the basic idea of active noise cancellation. You have a noise source, and in order to cancel noise, I have a secondary source that is going to be my anti-noise. When the two sources combine, the goal is to get, I'm going to reduce the noise. Now, what are my problem statements? My problem is that I want to reduce noise. There are some techniques that are passive techniques and active systems. Passive systems are very expensive or are materials that can absorb noise. And plus are costly and very expensive to do it because sometimes you have to install these devices in places that are not easy to do. This is my approach. In order to understand how my design is going to start, I may have this design. I have my noise source that is going to be in a conduit. I'm going to have microphones. The first microphone that is here is going to hear is going to be closer to the noise source. This microphone is connected to the active noise controller that is going to get information and is going to process all the information to the speakers. And plus I have an error microphone that is going to hear and going to catch the errors in order to go back to the active noise control to improve my secondary source. Well, this was my motivation. My motivation is there are unlimited useful applications for active noise cancellation. Uh, Another motivation is health problems. Noise can produce headaches and also hearing loss. There are also the lack of situational awareness. That because when there is a lot of noise in some areas, it's difficult to concentrate, or we can be exposed to some hazards. Also, with active noise cancellation, efficiency is going to improve, for example, in motors, and also we are going to get vibration reduction. The advantage of my design is that I don't have competition because all the devices that are in the market are expensive, and my device that I'm working on is going to be cheaper. And plus, I'm using a unique logarithm that is going to allow me to achieve my active noise cancellation.
You mean algorithm?
Yes. Oh,
Logarithm.
algorithm. Sorry. Uh, what is going to be my market? My market is going to be at the first place the landscaping for people who work in the field. My second market is going to be the consumer goods, for example, refrigerators, uh, washing machines, and the next market I'm going to concern is the big places such as power plants, factories, and offices. I'm looking for a profit margin of 60%. Uh, Here in my project demonstration, you can see that I test my design using one speaker, two speakers, three speakers, and four speakers. The result that I get with the red color is my efficiency. With the numbers of speakers that I have inside the conduit of the dock, I get more efficient. I improve my efficiency almost to 80%. But the downside is that the heat inside the dock is going to increase with the number of speakers. But when I have 4 speakers, my heat decrease. This is one of the papers that I read, Silent Night and Silent Days. This paper helped me to understand how size of blowers are going to affect the airflow that inside the conduit. Also, when I don't have the same phase, when I can have the same phase. Oops, what did happen? Okay. Sorry. Now, when I have different phases, instead of reducing noise, I'm going to add more noise. The next paper is Active Cancellation System of Acoustic Noise in MRI Imaging. This paper helped me to understand about the feed-forward control and the feedback control. Looking all the information that I have, I decided to use the feed-forward control because it's more efficient and it's working with my microphone error. The next paper, Modeling, Identification, and Feedback Control of Noise in Acoustic Dock, helps me to see and understand the pieces to achieve active noise cancellation. In this case, I have my microphones, my speakers, the docks, and also with the number of speakers, I can improve active noise cancellation. Now, my conclusion is with the number of speakers I get a better efficiency for reducing the noise. But also at the same time, I increase the heat inside the dock. One of the future work that I'm thinking is improve the heat dissipation inside the dock. Also create a logarithm that is going to find a secondary source locator, and I need to do more computation time. This is my literature cited. Questions?
Yeah, where is the research agenda?
Research agenda.
In other words, what will you do, and what do you expect to find?
In my research agenda. The thing that I want to find is, according to the logarithm that I'm working on it, with the number of speakers, I can improve the efficiency of active noise cancellation.
So, are you going to do this by building something?
Yes.
So you have a research agenda that includes a construction project?
Correct.
You didn't,
Oh, yes.
I didn't get that here.
Yes,
I mean,
yeah.
I couldn't figure out, I thought you were going to use multisim to simulate everything. And then I thought, are you simulating or are you building? Or maybe you're doing both.
First, I try to simulate using MATLAB.
So you're going to do a simulation.
Correct.
So is that part of your research agenda?
Yes, it might be part.
Okay, so that's part of what I would call the milestone.
Okay.
Right? Your simulations are going to somehow validate your hypothesis about how active noise cancellation can work. And then once that is done, because that's a barrier for proceeding, then you will have some sort of design that you can implement. So then you plan on building a prototype. Right?
Okay. Yeah, right.
So if you're going to build, if you're going to do simulation, and then you're going to validate your hypothesis with the simulation, and then you're going to use that design to build a prototype, that's a research agenda. And that should go in there with milestones and a timeline with deliverables, because that's the pitch. I want funding to do this research, and spec. And when I'm done, I will have a prototype that proves the concept, proof of concept prototype. So I'd say a research agenda that involves simulation and prototype building, these are very laudable goals, but they should be made clear. So it's up to you to set your research agenda. You could have said, I just want to do simulation and then I'm done.
Okay.
It's up to you. Other questions? By the way, this comment is the same for everybody. A research agenda tells us what it is you expect to do, why it is you are doing it, what it is you expect to find. So hopefully everybody here has a research agenda, because that's part of a thesis proposal. It must include some kind of research. Research by experiment, research by simulation, research by developing new theories on the blackboard, whatever. You could do this experiment between your ears. It would be okay. You must make it clear. Thank you.
Okay.
So somebody is next. Do you have a paper for me? Oh, it's stapled. Oh, you get extra points for it.
My thesis proposal goal is to design a motor that works under the temperature of 195 K, driest temperature, with efficiency and low size. So that for that I am going to use, like, I done research, like, search about this, and found two different ways. Like, one we can use superconducting material that exhibit superconductivity at driest temperatures, or we can use neodymium iron magnets that has low percent of efficiency, but we can have the magnetism at driest temperatures too with neodymium magnets. So this is my outline, motivation and research agenda. My motivation, like, what is the pain of this, what's pain, why I came to this proposal means, like, we have motors that works at regular liquid nitrogen temperature still now, but we don't have motors that works under 195 K on even. So if we have a motor that works at 195 K, we can have those, like, in cold countries. Those motors have market in the cold country. So this is the pain. And coming to advantage, we can have the motors that works under high temperatures, and we can have low size and with high efficiency.
Are you suggesting that we use these motors where it's 195 degrees K outside? Because I think it would be very cold. Is there a place on this planet where it's often 195 degrees K?
I mean
That's
that, like,
70 degrees C, right?
yeah, if we have in maglevs that, like, we can use those motors in the places where it is the temperature is 195 K.
What places are those?
I mean, we can have that one
You
in
mean like Antarctica? You mean inside of my cryogenic freezer? What, you mean places I can go? I can drive there?
I am going, like, I am telling this motor works under that conditions, but I'm not like
You mean like on planet Mars or something? I can my spirit explorer operating at the polar
George
center.
is going to design maglevs that so we can use these motors in.
Yeah, but I mean cooling would be required, and normally temperatures outside are quite a bit warmer than minus 70 degrees, even in the coldest of winters, even in even in Canada.
But every motor is designed with some type of coolant to cool those.
Okay, so it's these motors are actively cooled. Yeah. Okay.
And coming to research agenda goal, to create a low size, low quietness, high efficiency motor that works under 195 k. And what I have worked till now is like I studied so many motors. I mean, the motor designs with superconducting materials uh, that work under different temperatures. And future work, I'm going to experiment with neodymium magnets uh, under driest temperatures.
Oh, okay. Your research agenda appears to be devoid of any specific milestones or deliverables. What is it that you are planning to do? Are you going to build a
First
a
of all,
pre-prototype benchmark pre-prototype of
first
this
of all,
motor?
I want to uh, just had a conclusion about neodymium magnets. Are they gonna work under driest temperatures or not? Then I'll proceed with the simulation of the motor.
So you're missing those specific details in your research agenda. It sounds like your research agenda includes general experimentation with neodymium magnets, and then if they work, you will proceed to prototype something.
Simulate.
Oh, you're just going to simulate. And are you going to actually build a little motor? Maybe a homopolar motor with neodymium magnets and some sort of high temperature superconductor?
Yeah.
So that's in the cards too. So we've got a pre-production prototype, bench prototype
Yeah.
of the world's first dry ice temperature neodymium magnet based motor,
Homopolar motor.
which you will homopolar motor, which you will make. I'm very excited by this. This is very exciting. And it's not that you're going to actually build this motor and drive around, right?
I
It'll
can't,
just be a
right?
simple
Simple
prototype,
one. Yeah.
a bench prototype. That sounds like a real interesting project. Anybody else got a question? No? Did I talk you into building a prototype when you didn't want to?
No,
No, you
I want to.
Yeah, okay. So how can we find the materials needed for your high temperature superconductor? Can I buy this someplace? Like somebody sells this, right? Where do I buy these things? We're going to research that. I know I looked it up on eBay. They don't have it on eBay.
Yeah,
It's some exotic thing. What do they call it? This strange
want to
bismuth, lead, calcium, copper, oxide. What's tin? Also SR? Is that what SR is?
strontium.
Strontium. Oh, strontium. So it's a bismuth, lead, strontium, calcium, copper oxide conductor. Where do I buy that?
Those magnets are available in the market. But those can they will operate at liquid nitrogen temperature. So I'm going to experiment with neodymium magnets.
Those are liquid nitrogen temperature.
Yeah.
What about superconductors that work at CO2 temperatures? Is that the yttrium, barium,
No, not
no,
that.
cobalt?
No.
So what works at CO2 temperatures?
There's no superconducting magnets available that works at that temperature, but there is a material that works at CO2 temperature.
What material is that?
Uh, I mentioned.
It's not the
No, not
bismuth
that.
lead stuff, right? What's it called? Because you have to. Okay, so this is tin, lead, indium, barium. What's TM?
Tin.
And then what's SN?
Uh,
I thought SN was tin.
it's,
TM is not tin.
no, it's titanium, I guess.
Titanium is TI.
I'm
TM?
not good at
Is
chemistry.
TM an element? What element is TM? Timothium. It's made out of Timothy. I don't think TM is an element. Is this a typo? Okay, yeah, I don't think that is correct. TM is not an element, I know. But
I'm not good
chemist.
at chemistry.
If you told me TM was an element, I would believe you because I'm very gullible. But I don't think so. I don't know this element.
I'll make sure that.
Thulium? So TM is an element called thulium? Yeah. That's a big number, right? It's over 100? 69. Oh. What is... So thulium is it's made of thulium. Thulium, copper, oxide, barium, tin, lead, and indium. And so this is some very complicated compound, and apparently you can get superconducting
Properties.
tin, lead, indium, barium, timothium, what is it called? Thulium, copper oxide, and then it will work at dry ice temperature. We need this. How do we buy this?
Those
You can't
are
just
not
tell me it's
available.
on the market because
No.
I went to the market yesterday.
No,
for
those
food
are not
shopping, and there was none of that there.
Those are not available in eBay. I looked at it.
No, I know it's not eBay. But somebody, I mean, not Amazon, but somebody has this. How do we find
But
it?
I guess it's
Your
too
thesis, you have to help us. You tell us where this is obtainable. It's unobtainium, is what it is. It has to be obtainable if you're going to build a prototype, right? You need this. You need this.
Or like if the neodymium magnets work under CO2 temperatures,
Yeah,
I'll go.
forget the neodymium magnets. Where are we going to get this stuff?
Those are not
Does
available.
it have
If
a
you,
name?
its name is 1256 by 1212 structure.
It's called the
256 slash 1212 structure.
1212
Structure.
structure. 1256 1212 structure. That's a snappy name. Well, maybe we should call it We Need a Name so we can get suggestions. I'm going to suggest that we find a source for this material because otherwise we're not going to be able to build a prototype.
Yeah.
You are not going to be able to build a prototype. Thank you.
That one I'll do it.
Yeah, you must find where we can get this. You can't just tell me it's on the market because I can barely understand it. Okay. You could tell me it's expensive and it's $100, and I go to the dean and I say, give me $100. So we should do a thesis. And he'd say yes. It's more than $100? Is it more than $200? We have a budget. we can budget for these things, but I think we need to tell somebody how much. If you told me it was $1,000, I'd write a PO. But I don't know if I can get the dean to sign it. But I can make a compelling argument that he should. And then maybe he will. I don't get to spend that kind of money without permission. And neither, by the way, do you.
Hi.
Yeah.
This is about energy monitoring, and the abstract is it is mainly used to gauge the usage of power of a particular device and to monitor all the devices and to minimize the power usage And the main outline of this is about the motivation and the research agenda. And in the motivation first, what about the problem? Like uh, uh, we have to design an electrical outlet which which tells us how much power is consumed by each device, and then it should give us all the details about all the readings, and it should send us all the readings to a computer. And the motivation, this is mainly I mainly did this to educate people about how much power it is consuming. Like each device, maybe some device is consuming more electricity and we have no idea about it, and that device is not worth that much. So we can use this to see how much each device is consuming. And then this is a societal impact, like how is it useful for the society, and these are the ethics. It follows IEEE standards and about the safety. And because we are dealing with the high voltages, we can sell it in kits so that people will be safe. And then the research agenda, I just wrote it like how I want to do this. I want to just do a prototype for 110 volts right now, and after that I want to build it for 220 volts too, as in international standards. And for 110 volts I just wanted to use an Arduino microcontroller which integrates with the we can integrate it into an electrical outlet, and then Arduino logs the values, and then we can even use power line communication, which is helpful in communicating between the outlets. And then it helps us in routing the values. And about the contribution to this field, there is no electrical outlet which gives us the usage of power all at the same time, usage of power and then power line communication. And then I don't think anyone is using Arduino with the outlet. This is like a very new outlet, like smart outlet. So I'm using all these elements, but there are none in the outside.
You don't sound like you believe yourself.
No, it's like you were asking me about the contribution to the field from 4 weeks. Finally, came up with this. That's why.
So the contribution is that it uses Arduino, but that power outlet.
No, it's like we are building a new outlet, not a new device, which helps us giving this. But we are building a new outlet.
So the contribution is the integration.
Yeah.
So these will be smart outlets, and you'll be replacing the outlets with new ones.
Yep.
So this thing about a wireless power outlet system for smart homes, this is not a different outlet. It's just an instrumentation of existing outlets.
The that one is for the smart homes. That is the first thing which I told you. Like each device is connected to this, and for each device that is sent to the central hub, not to the home. And we can even control it using the mobile phones.
So when I look at the research agenda,
Yeah.
um,
I just wrote, I think, how we can use it, like how we can use it. Yeah.
it says here you're going to take an Arduino and a power line thing
Yeah.
and put it together, and it's going to transmit data.
No, I'm using Wi-Fi or Internet or Zigbee to transmit the data from Arduino to the computer.
So you take Arduino and you add Wi-Fi or Zigbee,
Yeah.
and then you add the power outlet
Power line communication.
monitoring, and then you have a system for measuring power usage,
Yeah.
and this is different from prior.
And we can even
because-
control those devices with the help by using remote controls.
So, if I were a patent examiner and I
Yeah.
told you this was obvious, you would say I'm wrong because.
because we have all the external devices, but we don't have any outlet in this way. We just have an external device which tells us the power usage and everything.
So the primary contribution is the integration.
Yeah.
And when you do a research agenda,
Yeah.
you should probably figure a timeline for the deliverables. So you want to have some kind of milestone and then the amount of time it takes to do the development.
Okay.
Because it sounds like there's hardware and software involved.
Yeah.
And probably you need one before the other.
Yeah. I have to. Yeah, I'll mention it next time. Yeah.
Yeah, so I'm thinking if you're sequencing this,
Mm-hmm.
there are subsections that you can work on. One might be the power line monitoring. Another might be the Wi-Fi communication.
Okay.
Another might be the integration between the two. And then the third thing you might like is some sort of I don't know, call it browser side application that can actually show the monitor.
Monitor. Yeah.
How are you going to communicate outlet measurements to the host computer?
Like
Wi-Fi, right?
through Wi-Fi.
And what will it do once it gets that information? Will it render it on the screen somehow?
Yeah, each outlet, I'm planning to give each outlet a name so that each outlet will have a name, and then we can see all the details. And I'm planning like if I do the software, I want the time and the power measured and the outlet name so that we can see like at what time this outlet is using this much power.
So maybe what we need is a picture that shows what you're going to see in the client.
Okay.
Does this communicate to the smartphone? Is this smartphone enabled?
I didn't think about it. If we try it, maybe we can do it because there are already so many people doing it. So
Well, I mean, if it's not supposed to go to the smartphone, does it go to the thick client, like browser?
yeah.
So you're trying to build some sort of browser application.
Yep.
So then I think you could probably draw a picture to sort of show a mock-up of what it's all going to look like when you're done.
Okay.
Some sort of visual specification of the software.
Okay. Yeah.
Okay. Any questions?
Shitan, you are up. My idea is about improving the maximum power point tracking for TSR systems. TSR systems are mainly they don't have dynamic characteristics. So my motivation is to improve the dynamic characteristics of TSR system. Why particularly TSR system is because most of the wind power systems running today are operated by TSR TSR control units. 60% of them are TSR control units. And my presentation is like I outlined all the prior papers I worked on, so I'll skip all this. It's just like I put outlines of every prior work paper. I'll skip to the last. This is a literature cited for my paperwork, and the research agenda. With this, I studied a lot of different dynamic methods and control methods that can improve efficiency of power systems, and I want to experiment on TSR systems with a serious unit included in it. It's like a control unit which should be updated in the present TSR systems, so that with variable speeds it should change the mode to HTS mode. it's like improving the efficiency of the present power systems. Uh, Talking of societal impact, it improves the energy efficiency, so more energy with less cost. Uh, More energy with less cost, and that's it. I mean, talking about ethics, it's it comes under utilitarianism, but which increases the energy generation, so making people more happy. And with safety features like it's a power generation unit, it should have some insulation suits and insulation precautions, and should be careful while installing these units. That's it. This is my research. I mean, my presentation is I didn't prepare for the outline of my midterm thing. I prepared all prior work outlines from the prior work.
Yeah, I think what's happened here is you went too fast through prior presentations, and maybe we need to see in your research agenda some sort of a Gantt chart. Are you familiar with the term Gantt chart?
You know,
Are there any questions? So we'll need a detailed research agenda about what exactly
Yeah.
you intend to do with your time, and what exactly you intend to
I want to-
prove and find. And then it has to be shown with a timeline. So how much time it's take for each step in your research.
oh, okay.
So let me see if I can find some information about Gantt charts. Are there any other questions? Presentation on Gantt charts at some point. Has no one ever heard of a Gantt chart?
It's just a map chart, right? Showing all the details about the country.
Yeah, your Gantt chart or PERT diagram, that's another one, is a way in which you can manage your project. I'm going to skip George for now. We'll go right to Raoul. I'll talk a little bit about Gantt charts later. Let's do Raoul first.
Good afternoon, everyone. My thesis proposed is wireless transmission of power using the fractal antennas. So, coming to the research agenda, and the first point is like goal. The main theme of my thesis proposal is to transmit the power wirelessly, but using fractal antennas. There are some experiments conducted on the same concept before, but my goal is to increase the efficiency, because the previous paper, in the previous papers, the efficiency was like around 50%. So I would like to contribute my effort to the field and increase the efficiency to up to more than 75%. And coming to the difference between the previous works and my work, the previous researches were conducted with a very low frequency, like they used a 2.45 gigahertz microstrip patch fractal antenna. But what my idea came up with is like to use a more higher frequency and and get higher efficiency at the receiver end. So I am going to use a frequency band of in the range of 1 gigahertz to 15 gigahertz. It may vary depending on the power we assume to be found at the output. So and coming to the analyzing the result, we will calculate the power at both the transmitter end as well as the uh, receiver end, so that we can calculate the efficiency, and the efficiency can be analyzed. I believe we can get a more efficient power by increasing the frequency. And coming to the pain, um, like when we use the wires for transmitting the power, there may be like some unpredictable accidents that might occur, like for example like short circuits and fire accidents or anything which may be like hazardous and dangerous for the people living surrounding the environment. So and also even the maintenance and repair of the wires is also a difficult job, because they are like hung up on the top of the poles. So a person needs to climb the pole and repair it. It might be like a tough job. And coming to the advantages, we can reduce the usage of plastic that's like wrapped around the wires, and the need for the batteries is also minimized. The batteries actually take a very long time to degrade, so this makes our world like eco-friendly. And also by using this concept for transmitting the power wirelessly using fractal antennas, the installation of any equipment will be like very easy and simple. And coming to the market, I believe I have a very wide range of market because of its because it has so many advantages, and we can use it in numerous applications, like in military or in the hospitals, like which consume low power. So I think this has a very wide range of market. Thank you.
So I'm thinking that you need like a slide with the references, maybe one or two paragraphs for each reference that you cite here. So if you have
18.
18 citations, there should be at least 18 paragraphs
In
describing
the present,
one of these with each one of the citations. And then
like in the presentation,
well, maybe not in the presentation, but
in the
certainly in the paper.
okay.
And then I didn't see a detailed research agenda, so I think maybe we need to talk a little bit about research agendas and what it means to create them for our thesis.
Like this, like the even the previous papers are not patented. Um, well, for example, the Sierpinski fractal antenna, even that is, I couldn't find it in the uspto.gov. So the efficiency was around 50%. They used a very low frequency microstrip patch fractal antennas. But what I was thinking is, if I can increase the frequency and keep in mind the FCC regulations and transmit the power, I might get a higher efficiency, which might be like a very useful and useful for the people.
So I'm thinking that you have to have some sort of simulation. Are you going to simulate this?
I mean, if I can, if I have the necessary components, I could simulate it.
You have what now?
The necessary components, like to increase the frequency and the fractal antennas.
Is there software that can simulate fractal antennas? I don't even know.
I did not find anything about the
Yeah, I mean, if
so
you
for the
can't
simulation.
simulate it, then you're going to be in a loop about prototyping and testing. Because without simulation, then the only research you can do is by experiment. So if you're going to do research by experiment, then you must prototype, and test.
I mean, we can use the same antenna, but we'll operate it in different frequencies to
so then
test
that's part of the so part of the prototype, you'll have one prototype, and then you'll test at different frequencies.
yeah.
And then after you do that, you may go back into the loop and try a different prototype, and then test that at different frequencies. So So, for
Yeah.
example, you might say, let's try a simple loop, right? Just a curl, or a circle. Then you can try it again only with fractals. Then you can try it again. Then try it again maybe with different antennas. So as far as I'm concerned, a research agenda built in experiment must be heavy on prototyping and testing. And I think that's a very fine thing, research by experiment, but then it has to be made clear that
Okay.
you don't have simulation software, therefore you cannot predict how your design is going to perform.
Yeah, I understand.
And if that's true, then you may say that your prototype will be different from a prior prototype because you have a different level of detail in your fractal. Or you may have a completely different fractal. You may
Yes,
say
maybe,
Sierpinski
yes.
carpets are different from Koch curves, and maybe the two are performing differently. Which one is better? I don't know.
I mean, we need to operate every
Yeah,
antenna
I
at
mean, if you
different
told me I'm
frequencies.
going to prototype Koch curves, test them at different frequencies, then I'm going to prototype Sierpinski carpets, and then test them at different frequencies, you might be able to turn around and say at different frequencies, one is better than the other. That'd be very good information. That's the
Okay.
kind of information. Then you can compare it with regular loops.
Yes.
So now
yes.
you've got three different kinds of prototypes you want to build. Koch curves,
And the
Sierpinski curves,
yeah.
Regular inductor loops, and then you want to test them at different frequencies. You've got a
and
real
calculate the
research
efficiency
agenda.
at every
Yeah, I mean,
frequency level.
That's not a trivial amount of experiment. That's high overhead experiment, but it's a good experiment. So it sounds like you want to propose a series of experiments because you cannot simulate your fractal antennas.
Yes.
Yeah, if you told me, no, Professor Lyon, you're wrong, I can simulate fractal antennas, I would say I'm very happy to hear that, because this prototyping and testing loop is going to get you really hung up on experiment.
Yeah, I understand.
Now the other thing is,
I will see if there is any simulation software and
you're
anything.
going to want to try look at power transfer
Okay.
efficiency, I should think.
Simulation of power transfer.
Well, you're not simulating if you're prototyping and testing.
Yeah.
So,
I mean,
so
I will look up in the internet if I can find any software that can like where we can simulate.
I don't say there isn't,
Uh,
but I don't say there is either. I really don't know.
yeah.
So
I mean,
you have to tell me.
from the previous papers, I couldn't find any software that that they used for simulating.
So what it is you will test for is the power transfer efficiency,
Yes.
and then
And
you
the
will do
process.
that at different frequencies.
Yes, and the main process is that at the transmitter end we convert them into the microwaves. We transmit the microwaves in the free space. At the receiver end we capture the microwaves and convert into the DC the current. That is the main process, but we do the same thing at different frequencies in like with the different kinds of antennas.
So if you have different frequencies in one direction and different power transfer tests in the other direction, then you have a two-dimensional spreadsheet which is being used for one design.
Yes.
And that might be something like a loop. Then you have to repeat that whole spreadsheet of gathering data, and you change frequency and measure power transfer test efficiency
Yes.
in the other direction, and that might be for a fractal, like a Koch curve.
Yeah, for
Sierpinski curve.
for one thing,
Yeah,
and
so-
again do it for another
So you
antenna.
need to make a separate table for each design.
Yes.
So one table per design.
And it's kind of a long data sheet I might get.
Well, I think there's no help for it,
Yeah.
because you have to gather data. Because you say you can't simulate it, therefore you must prototype and test. Right? That's a lot of work.
So, the way I would do it
is something like this. Since simulation is not available, I would be in a, I'll call it research by experiment. That's your mode, right? So you're going to do a series of experiments, and so you'll have a design, and for each design, each antenna design will map frequency versus power transfer efficiency. And we'll have to show the different frequencies going one way and power transfer efficiencies going the other way. And then we'll do the same thing with a different design. Now, do we also have to care about the proximity of the two antennas? Because now you've got a third dimension that you have to measure. Like how if it's a foot away, it transfers data. I mean, frequency versus power transfer efficiency is something you could do for a fixed distance. But if you change the distance, I imagine there's inversely proportional to the square of the distance away rule that changes your transfer efficiency. But maybe not as a function of frequency. So this needs to be done for each distance that you select. And now, so for each design, you're going to have to do frequency versus power transfer efficiency, and you may select specific distances, 1 feet, 2 feet, 10 feet, something like that, 4 feet. And now I'm for designs, maybe you would do something like this. You would do the loop, and 2 fractals, Sierpinski, versus Koch curve. So now I've got 3 designs to think of. So that's a lot of experiment, but you've got to do it, right? Because you can't simulate it. Unless I'm wrong, and you can simulate it. But that's, I mean, your research agenda has each one of these designs has to be fabricated and then tested, tabulated, and you need another design to fabricate. That's a lot of fabrication, a lot of design work, and it takes time to make printed circuit boards. George, we got you last. Yes, yes, and I'm collecting printouts if you have it with you. Great, great.
Hello everyone. Alright, just before I start, the homeworks weren't necessarily in order. I just looked at basically what we did, and some of them weren't in the right, they weren't like numerical order necessarily, so bear with me. So for homework 2, which I believe was it was the one where we had to solve, we chose a problem and we had to go through the different steps. What I chose, I guess, this was before I had this was a different idea. I had a different idea for my topic several months ago, so it's obviously different now. So how I outlined this was, you started with a problem, you had a motivation for a problem, why is this problem important, approach to the problem. This is basically, it's like this is kind of like an intro to a thesis, how to solve it. This is kind of like the first basic steps. It's pretty, not too difficult to understand. Next homework assignment I had was the PPA, the provisional patent application. I guess what I chose for mine was a ferromagnetic maglev defense mechanism force field. Mouthful. Basically, I had the abstract, the prior art, and the claims. I guess I didn't really elaborate as to what they were, but don't think that was really that important. Alright, it is obvious. This one was kind of a long one. We first had to had the original claim, we had a revised claim, prior art, and then we had to prove that wasn't obvious, it is not obvious, followed by scope and content of the prior art, level of ordinary skill in the art, differences between invention and prior art, objective evidence of non-obviousness. Societal impact. This is, I guess, was a fairly important one because this is what we have to. This is one of the parts of our thesis. So, what I chose was my title of mine was societal impact of maglev defense system. My 3 steps were I outlined them as safety, future exploration, and conclusion. The paper list. This is basically, this was for my first topic, which I later changed, so these aren't necessarily relevant to what, but they're, I guess, good to know. So for paper list, the first one, you can see, you can read the different titles. I don't think I need to read that for you. A through E, so 5 topics. And the 8th homework assignment was just basically continuing that, so there are 5 or 4 more there. And the ninth assignment was just citations. I didn't feel like listing that because I think that it would just take too much space up, so I just called it 1 through 5 Roman numerals. Not really. Nothing really there. The talk, which we did last week, I basically simplified that as what we had to do in the presentation, which was pain, advantage, market, or I guess the advantage could be replaced with I forget what you call it, the sustainable competitive advantage. Also be known as that. The research agenda. All right, so this is what I did for mine. I believe it follows the basically the outline you gave us last week. So for mine, the goal, I start with a goal. My goal is to build a prototype of a plasma radiation shield and test its ability to deflect solar radiation protons. This will start as a prototype, and I'll test its ability to deflect solar radiation, and once I've done that several times and can see that it's that's when it will possibly be used. Obviously, you don't want to start with building this whole spacecraft before you know if it's able to, the shield is able to block radiation. In my case, I will do experimentation, so that's how I will validate my. I need to get consistent results and possibly simulation for me, because I have a lot of different variables in my, I have to test the magnetic field, the shielding strength, there's so many different things that I have to do. So I think I'll probably have to do simulation, maybe use perhaps MATLAB or some other numerical method, because for example, I could build the magnetic field to with the different number of coils, but depending on how much I want, but the shielding, and then also testing the strength and for example, like the material that will be used to make this will be in a toroidal shape, like in the shape of a donut, and that you'll have to test the insulation and its stability. So there are many different things that you have to test that aren't necessarily that I focus on, that I don't necessarily focus on my project. Experimentation, basically, I will test these results until I test these different variables like magnetic field strength and the shielding properties until I get consistent results. That's basically what experimentation is. And I haven't, and the rest of what worked, what didn't work, future work, that hasn't been, I left it out because that hasn't really been determined yet. So I will have to obviously start my experimentation and to know what these what the answers are. So that's what I did. Any questions?
This is probably my fault, but what we want to do is get a PowerPoint presentation that approaches the final presentation of your work.
Oh.
So when you're looking at your prior presentations, if you saw, like you went down a path of an ag-lab research, but then decided to change your path,
Oh, okay.
that wouldn't necessarily have been included. So
Well, I guess I misinterpreted it.
It's my fault. I wasn't
Because
clear.
I thought you wanted like want us to all the prior, yeah.
Yeah, I see what you did, and I can understand why you did it.
Okay.
What we're trying to do is get to the final PowerPoint presentation for the class, which allows you to
okay.
present your
It's like final.
thesis proposal to others.
I see. That makes more sense.
And
Yeah.
that's going to include all of the things that we worked on separately, including societal impact and motivation and research agenda and ethical considerations and the planned experiments
Okay.
and the milestones you intend to achieve. So at some point,
I guess we'll
perhaps
have.
next time,
I'll
we'll go through this again.
Okay.
Only we're going to have a PowerPoint presentation that feels like it's almost done. I'm really focused now on let's finish this course because
No, I understand.
semester is done. I don't know if you've noticed. There's like hardly any semester left, no time. So
okay.
If this is 15 pages and you were planning on submitting 30 pages, then you've got 15 pages to write between now and the end. So if you're thinking that you need, to have done a little bit more, like write a paragraph about each thing, and you didn't really write a paragraph about each thing, then there's a lot of writing to do.
Right.
If there's no detailed research agenda under approach, don't quit out of Camp Studio.
I won't.
Yeah.
All right.
So what I would like to see is our presentations approaching done. And so what I'll do is let's stop this for now and take a break.